Good days, professors, senior scholars, and colleagues. My name is Engineer Gasifier. I'm here to present a paper entitled Partial Gasifications of Different Types of Biomass in a Fluidized Based Gasifier. This paper is jointly authored by Dr. A. Dare at University of Ibadan and I.A. Adeyemi at Obafemi Awolowo University, Nigeria, and Festus Ademola at the Polytechnic, Ibadan, Nigeria. The partial gasifications of coconut shell and sawdust have been studied in a laboratory scale atmospheric fluidized bed gasified using air and air steams as fluidized media. Determinations of the producer gas compositions were conducted using gas chromatography, and partial gasification experiments were conducted at the bed temperature of 600 degrees centigrade. The comparisons of the producer gas compositions while using air and air steam gasifying agent were conducted. Then introductions of the steam had shown significant increase in the carbon monoxide, carbon dioxide, methane, and hydrogen content in the producer gas compared with the air as the sole gasifying agent. Introduction. Gasification is a clean technology. Then the present good prospect of biomass used mainly for producing electricity with high biomass conversion efficiency and low environmental impact. It is a technology to convert biomass, solid and liquid fuel, into flammable gas and could be applied to combine cycle power generations with this fuel. Biomass steams and oxygens or air are reacted together to produce a gas containing hydrogen, carbon monoxide, carbon dioxide, nitrogen, methane, and other hydrocarbon compounds. This gas is clean to remove particles and sulfur compounds. Gasification technologies can use all types of biomass, and it can be linked with combined cycles, nitrogen combined cycles, to produce power efficiently, or it can be used as a source of synthesis gas for chemical or fuel gas for homes and industries. Gasification technologies offer the prospect boosting efficiency to 45 to 50% in the short term and potentially to nearly 60% with technological advancement. These studies was conducted in alignment with the advanced functions of the combined cycles. Plant involve partial gasifications of biomass in a pressurized polymer instead of its complete gasifications as done in an IGCC according to basal typical gasifying pyrolysis or partial gasification process takes place at temperatures of 150 degrees centigrade to 700 degrees centigrade. With that, the selected temperatures of 600 degrees centigrade were used throughout the study to represent the partial gasification process. And the aims of these studies are A, to determine the producer gas compositions, and B, to study the influence of the different gasifying agents in the partial gasification process. The experimental test rig composed of the following. 1. We have distributor plate. Distributor plate distribute here for fluidization, and then we have plenum. Plenum take the air to distributor plate. Then 3, we have thermocool probe point of entry. This is being used to measure the required temperatures of the bed. Then 4, heating coil is used to heat fuel. Then 5, lagging compartment to prevent loss of heat to the atmosphere. Then 6, fuel feeding device, and this is to supply fuel to the distributor plate. And 7, which is the final one, combustors, where combustion take place and where the waste of fuel is being finally converted into the flammable gases. and the device can be used to burn the waste and any type of fuel irrespective of percentage of moisture content. So waste like coconut shell, sawdust, this is being used majorly for biomass products as above samples. Operational principles: the blowers will be on and the motors for the feeding devices will be switched on, and the heat coil as well will be switched on. So the fuel valve will be opened for fuel to enter the combustor before the fuel is being passed on to the combustors, and the heat coil and then the blowers must have been switched on immediately. The fuel enters the combustor and it will start burning, and the exhaust will be filtered by the limestone in the cyclone, which will make the exhaust gas coming out of this device with less or no poison. And if they want to use it to power generator to generate energy, then the turbine, which will carry water, will be passed into the combustors, and thus the water will be turned into the steam. The water will turn into the steam, having boiled through the passage it passes through, or in the combustors, will now be used to power the turbine for electricity generation. But in line with this, our research will limit us to the measuring of the temperatures to determine how suitable it will be to generate electricity. So partial classification of different types of biomass in a fluidized bed gasifier. Fluidized bed gasifier, this will turn waste into flammable gases, which could be used in future, and it has high efficiency of about 55 to 60% compared with the existing one that has 45 to 50%. It can convert any type of fuel into gas irrespective of the percentage of moisture content, and the same apparatus is being used for the combustors. But in gasifier, the little difference between combustors and gasifier is that there is decrease in the heat capacity of the heating coil of about 150 to 200 degrees centigrade as compared to that of combustor, which has a temperature range of about 400 to 500 degrees centigrade heating capacity for heating coil, which is capable of generating 917 degrees centigrade of heat. The major difference is that the gasifier did not generate heat. It will only turn waste or fuel into gas. The reason why it needs less capacity heating coil, and the gas could be used to generate heat in the later day. Feeding rate of feeding devices in the fluidized bed combustors is measured in kilogram per hour to determine the highest bed temperature for the combustion process for highest efficiency. And we use the graph of gasifier to determine various gases emanated from the process and their heat capacity for future use. Conclusively, a laboratory-scale fluidized bed gasifier has been developed and operated for partial gasifications of biomass with air and steam as the gasifying agent. The performance parameter, which is the product gas compositions, have been studied, and in this study, it was found that the combustible gases, hydrogen, carbon monoxide, and methane, were significantly higher in air-steam partial gasification process compared to the air partial gasification process, and the effect of the biomass rank was less significant in the studies. So the quality of the producer gas, which was assessed through the calculated LCF, that is lower calorific value, also had improved as the steam was introduced as gasifying agent. Thanks.